And we will turn it over to our speaker, Art Hirsch, on the topic of microplastics.
Thank you, Chelsea. Hey, Chelsea, is there a way that we can get rid of these pictures of ourselves? Or I can just click it away. There we go.
Yes.
I think I'm good. Okay.
Perfect.
Okay. Well, good morning. Good morning, everybody. And I want to thank you for attending the presentation. I think it's a very important water quality issue in the Great Lakes that I'm going to be discussing today. And it's really a really complex issue that I'm going to try to explain. And this problem is not just in the Great Lakes. I'm going to be talking about. I'm going to be focusing my talk on, but it's throughout the planet in terms of how ubiquitous plastic is within the environment. As Chelsea mentioned, I'm a former environmental engineering consultant. I'm a recovering environmental consultant. I've been retired for almost 3 years now. As an environmental consultant, my major client was the Colorado Department of Transportation for numerous years, doing environmental impact studies and also a lot of water quality studies as are related to stormwater activities and impacts. So I thought that I'd start off really with the main purpose of my presentation. And the thought is really to increase your awareness and interest in this emerging water quality pollutant. And it's like I said, it affects the Great Lakes in a very big way, especially since the Great Lakes comprises over 20% of the fresh water on the planet. It's very important that we protect its integrity and water quality. So the main theme that I'm going to be talking about today is there's three main themes in regards to the microplastics. The first is that microplastics do represent an impact to the physical, chemical, and biological attributes of the Great Lakes. And this has been shown, these impacts have been shown to be relevant from research work that has been done in the Great Lakes by numerous universities and agencies around the Great Lakes area. The second thing is that it's kind of a common theme is that more research needs to be done. I expect, especially in regards to sources of microplastics and also their impacts and ultimately to the environment and ultimately to us humans that live around the lake. And the third thing is that this is a complex issue and it needs more attention by both federal, state, and local governments and the general public. So with that introduction, I guess I'll start off with the talk. So I'm 68 years old, and I've lived on Lake Michigan all my life. I'm originally from the Benton Harbor, St. Joseph area. And then during my adolescent years, I lived up in the Muskegon area, again, living on the lake. And so during my 68 years, I have witnessed a lot of abuse to Lake Michigan. And this is just some of a laundry list of things that have happened to Lake Michigan and how it was abused over time and still is being abused. Early on, there was a lot of direct discharges of raw sewage before the Clean Water Act was initiated back in the 1972. There were a lot of industrial discharges occurring into the lake, especially the southern part of the lake, the Gary, Chicago, Waukegan area, where a lot of heavy industry was happening and a lot of heavy metals and petroleum were being discharged. We've had problems with freighters, with oil and ballast discharges. Then back in the 80s and 90s, there was problems with detergents, in which are getting huge amounts of algae that were occurring in the lake. Then we have issues of invasive species, and alewife, zooplankton, zebra mussels, things that have really affected the integrity of the lake in terms of biological integrity. Then we have the issues about overflows of stormwater, lake productivity reductions. Now we've got a relatively new player, so to speak, perfluoroalkyl substances, or PFASs, that are getting a lot of attention to a lot of states associated near the Great Lakes area, primarily a concern of drinking water. And also the PFASs have also gotten into the tissues of various types of fishes, and there's fish consumption advisories within a lot of the Great Lakes states. And finally, emerging pollutant is plastics and microplastics, which is, I think, a huge, huge problem, as I'll get into. So with that, again, that introduction, let's get into what, talk about plastic gyres. And many times people think that the gyres, when you think of plastic pollution, they think of the ocean, and gyres are really basically just circulation patterns of the ocean based upon the actual gyration of the planet, called the Coriolis effect. And what happens is that these circulation patterns start to accumulate more and more garbage, litter, etc., from various countries. And so the largest one is in the North Pacific, and it basically accumulates a lot of plastic material from North America, South America, and also Asia. Probably the largest contributors of the area is China, Malaysia, Vietnam, and a bits of Japan. So those are really the plastic gyres that many of us think about. This is just kind of a picture of what they look like. You've seen these probably on the news before, where large amounts of plastic accumulate. And just to give you a sense of scale here, it's 617,000 square miles of plastic. Again, 7 times the area of the state of Michigan in regards to how huge these things are. Well, the Great Lakes kind of has its own gyres in a way, in regards to its circulation patterns. And this here, you can see the lower part of Lake Michigan. You get this counterclockwise motion of water within the lake. Again, creating this, if you want to think of it as a gyre in a way. And also Lake Superior has its own circulation patterns, again in a counterclockwise area, and also Lake Huron, Lake Erie, and Lake Ontario. So again, these circulation patterns has a lot to do with the accumulation of plastic that occur within the Great Lakes. And this graphic over here down at the bottom right shows the accumulation of particles of plastic material in the Great Lakes. And the yellow meaning that probably it has the highest concentration or particle density in the lakes. So the yellow, you can see it really gets involved with the lower part of Lake Michigan, again, near the large metropolitan areas, Chicago, Milwaukee, in this particular area. And also in Lake Erie, you can see the Detroit area, Cleveland, also having an influence, in Lake Ontario with Toronto and other cities have a huge influence in regards to the amount of particles in the open water. So it kind of gives you a sense of kind of what we're talking about in terms of these patterns and mobility of plastic in the Great Lakes. So plastics, it's a really complex issue, as I've mentioned, and it's everywhere. It's it's in our quality of life. It's basically ingrained or embedded into how we do business in the United States, if not portions of the world. We use plastic for numerous types of things, in very good ways in regards to medical applications. Car parts are very important in terms of plastics because they provide lower weight of the plastic of the vehicle, and therefore increases gas mileage. But there's also problems associated with how we manage plastics. You know, we see plastics being used, they're called single-use plastics that grocery stores, retail stores, you know, basically give the consumers to use, and people use them for maybe like 2 or 3 minutes and they throw them away. Down here, you can see large amounts of plastic being generated here in the United States and shipped to Malaysia and also Vietnam for them to manage instead of the United States. So we get a lot of plastic generation from, you know, from styrofoam materials, also drinking water bottles. There's a huge consumer of plastic, and the plastic that we use to control and package our vegetables, our fruits, our food. So again, it's a really complex issue about how it's really integrated into our society and our quality of life. So a little bit of discussion about plastics. You know, plastics is a commonly used term to describe a synthetic or semi-synthetic material. Really, you can think of it as a long chain of carbon atoms put together, manipulated with various types of additives that provide these various types of products. They're made primarily out of crude oil, out of natural gas and crude oil. Various types of fracking areas, excuse me, various types of fracking distillation areas. And these are very energy intensive in terms of making plastics. So packaging is about 40 to 50% of all the plastics that are used and manufactured. Beverage containers, followed by other types of uses that I kind of showed you pictures of, from medical to piping, etc. So this is just a laundry list of really some of the common plastics that are manufactured in the United States. This is just a subset of the total number of plastic polymers. But the ones that are highlighted in yellow are really the ones that we're seeing a lot in terms of microplastic generation. A lot of the trash that we see on the lake, on the beaches, and various places that we go in our normal days of life. High density, the polyethylenes are really common because they're in shopping bags, milk jugs, you know, and also bottled water. We go down here over, and then the PETE, again, bottled water, food containers, polypropylene, straws, packaging, egg cartons such as polystyrene, and PVC, which is used in piping and flooring and these sort of things. So just kind of give you a laundry list of the type of plastics that we're dealing with, and the primary ones that cause us the most problems in terms of microplastics. So there's a lot of things going on in this graph that I wanted to point out. The first thing is that you can see this is here is the cumulative million metric tons of plastic. This is really plastic waste that's being generated. And plastic waste generated is really mirrors exactly what the operations or manufacturing of plastic waste is. So one way you could look at this is the growth of plastic manufacturing that's going to be occurring between now and 2050. And you see this huge increase in plastic manufacturing that's going to be occurring within the next 30 years. Just within the next 5 years to 10 years here in the United States, the amount of plastic that's going to be manufactured is going to increase by 3-fold. And a lot of these new manufacturing facilities are going to occur in like Louisiana and also in the Ohio River Valley. So it's a huge problem in terms of the amount of material that's going to be generated and how it's going to be managed. In terms of a perspective of greenhouse gas emissions, by 2025, 55 million tons of CO2 is going to be generated from 42 new plastic plants in the world. So that equates to about 27 additional coal-fired power plants that are going to be online and discharging greenhouse gases. So it's quite high. And the other thing I just quickly want to point out is here we are in 2030. Excuse me. What's happening is that here's the total amount of plastic being manufactured is at this point here. At this point from here down is really the plastic that's actually being managed by incineration or by recycling. So there's this huge gap here that ultimately the plastic ends up in the environment, in the air that we breathe, the food that we eat, and the water that we drink. It's in the environment. So anyway, quite stunning, I think, in terms of you look at the pure mass of plastic that's going to be manufactured and not managed. So the problem with the plastics also, just their sheer numbers, is the types of chemicals that are added to the plastics. They're called endocrine disruptors, and they're really toxic chemicals that really affect the viability of us as humans in regards to reproduction. And they affect fertility, and they can even affect the development of unborn children. So this is a real problem in regards to plastic uses and the use of endocrine disruptors for various types of chemical reasons. There's BPA, which is used for coating cans that are used to contain food. There is phthalates. They're used for softeners that basically mold the plastic, makes it flexible for various types of applications. And alkophenols. They're used for fragrances and thermoplastic oxidizing. So again, a lot of these things are endocrine disruptors. And then we have the PFAs, the PFASs, which are added for flame retardant purposes. So one of the things when you look at this in regards to endocrine disruptors is this, you kind of note this relatively new statistic is that the fertility rate in the United States has decreased primarily in males by 30% over the past 35 years. And one wonders about our exposure to endocrine disruptors like these plastic additives and the other types of chemicals that we get exposed to here in the United States. So it's a very disturbing piece of data here. So let's talk about loading into the Great Lakes. 22 million pounds have been estimated of plastic enters the Great Lakes per year. It's a huge amount. I can't even put my arms around how huge that is. And Lake Michigan is number one. 11 million pounds per year it receives from. So it's number one in the Great Lakes, followed by Lake Erie, Ontario, Huron, and Superior with lesser amounts. Most of the litter that we see on the beaches, I'm sure you have when you walk the beach, is 80% of that litter that we see on the beach is really plastic material. So what are microplastics? Well, microplastics are pieces of plastic that are less than 5 millimeters. That's 3/16 of an inch. So you can actually see it. You can see this picture of this microplastics within somebody's hand. So it's a material, it's a size that you can see in many respects. It's the highest size, but it also comes into very, very small sizes called nano sizes. So the primary plastics are plastics that are produced at 5 millimeters or less, just specifically for an industrial purpose. So there's a lot of industries that use what microbeads that are microplastics, specifically for paint removal or rust removal. Microbeads used to be in a lot of cosmetics and toothpastes, and plastic. And there's also things called plastic nurdles. I'll talk a little bit later, but they're also related to plastic manufacturing. Again, less than 5 millimeters. So the secondary microplastics are really degradation products, degradation of large pieces of plastic. Large pieces of plastic that get exposed to the sun, wave motion, various types of abrasion, and ultimately gets into the water. Microfibers from synthetic clothes is another source that I'll talk a lot about in my presentation. And again, we get into these nano plastics that again are very, very small, 1 nanometer, micrometers in size that you just cannot see, but are probably the highest risk form of microplastics because it can get into the fish and actually into the fish tissue. So these are the types of microplastics that we look at. These are the 5 basic shapes and sizes of microplastics. The fragments that you see when you're walking the beach, a lot of these types of fragment materials, again, less than 5 millimeters. Then we get into the pellets. Again, these nurdles, these pre-plastic size materials for plastic manufacturing. Film that comes off of various types of plastic bags, potato chip bags, etc. Styrofoam. Foam is another form of microplastics. And then we get into the more of the micro fiber looks. And so each one of these has their own unique density in the water and shape and size. So it really affects the fate and transport of the material in the Great Lakes. So a really quick picture of microfibers. When I was starting to do this work several years ago, I was really surprised. I thought the major problem would be the more of the hard plastic materials in the water. Well, the number one problem is really microfibers. They're a secondary microplastic, and they're a degradation product that really comes off of a lot of the clothes that we wear, synthetic clothes. So these are really being taken up by a lot of the organisms within the Great Lakes. Studies have shown getting into the food chain through the fish. So this is a graph, again, very similar to what I showed you in terms of plastic manufacturing. This is a clothes manufacturing, fiber production. And you can see the synthetic clothes that creates these microfibers. It's not going to stop. It's continuing to move up and up based upon consumer demand for various types of synthetic clothes, where you can see cotton, the demand for cotton and wool has really been very stable, since the 1980s. Plastic fragments, again, this is kind of a snapshot of what they look like. They're dominant mostly in surface waters of the Great Lakes. And when you get far out into the lake, they'll dominate. They have high surface areas, and they're very likely areas of collecting toxic materials. Again, I'll talk about that in a little bit. But these are the plastic fragments that we're kind of used to seeing. So the USGS, the United States Geologic Service, went in and did a sampling of 27 tributaries in the Great Lakes. And they basically came up with this type of size distribution or fabric distribution, or microplastic, excuse me, where fibers is number one. 71% of microplastics that were sampled in tributaries are primarily these microfibers that I had talked about. The next are the hard fragments type materials, followed by foams like styrofoam, films, and beads. So then you can see kind of a distribution here in a lot of the rivers that discharge into the Great Lakes. The next one is kind of a real interesting slide that I could probably spend an hour talking about, but simplistically, the top graph here is really plastic density, plastic per, particles per 100 gallons. So this is kind of a graph showing those types of concentrations or densities. And the bottom part is more of a corresponding graph that talks about the land use within the watershed. So the USGS did a really good job in terms of putting this into some sort of a watershed perspective and looking at it. And so just a couple things that I want to mention is that you can see fibers, the blue here, really dominate in most all the watersheds, they're the highest concentration or density of any place. And also, as you may suspect, that places with a high urban development, in the red here, really has high concentrations of microplastics in their neighboring tributaries, which is really not much of a surprise. So that kind of gives you a perspective of kind of the distribution in terms of a watershed perspective. Let's talk about the sources. I'm going to try to go through these really quick. Many of you may know this already. One of the major sources of microplastics are wastewater treatment systems. You would think that that makes a lot of sense because it collects wastewater from domestic areas, domestic sources, industrial sources, and also from storm sewers in many locations. So this makes sense that there's going to be a lot of plastic within this particular area. And then you have industrial discharges. Again, these types of plastic materials, these beads that are used for various types of cleaning, even in detergents, there's microplastics used for industrial purposes. The microfibers, as I mentioned before, just the amount of fibers that are released from cleaning synthetic clothing, like our Gore-Texes and our various types of outdoor gear, etc. 700,000 fibers per load. It's an amazing amount of microfibers that get released just by washing synthetic clothes. Just by using Tide or All or various types of detergents, there's a huge amount of microbeads that are being discharged just by detergents. And then finally, the tumble dryers. They generate a lot of fibers themselves just by the exhaust of the dryers. So, 500,000 fibers per load is some data that I have gotten from United Kingdom. So anyway, it's something to be aware of in terms of how the types of clothes that we buy and how often we wash them. Other sources, you're very familiar with this, seeing a lot of trash, a lot of plastic materials on the beaches that basically get beat up through the sun, through the waves, and ultimately end up in smaller pieces. Cigarette butt filters. Car tires are an interesting source of plastic material because the plastic tires shed these hard pieces of plastic in very, very small sizes that ultimately end up in the storm sewers and into the tributaries and into the Great Lakes. Agriculture, it's an interesting one because this is a lot of research needs to be done on this. A lot of work has been done in the United Kingdom and in portions of the United States in regards to stormwater runoff coming off of agricultural fields and how that impacts water quality related to microplastics. One source of microplastics, and a huge source potentially, is the use of biosolids as fertilizers on agricultural fields. It's like 55% of the wastewater treatment facilities in the United States use this technique of applying dried sludge that comes from a wastewater treatment plant, drying it and applying it onto a farmland. These things are just full of microplastics. And I'll show you some data about its recovery of microplastics from wastewater treatment plants. But the problem is that stormwater hitting this material, flowing into ditches and ultimately into tributaries can potentially bring in a lot of plastic material into the watershed. Next source of agriculture is plastic mulch. This is used in Michigan primarily for vegetables, strawberries. And once this material is done for the season, the farmers will roll this up and either set them on fire or try to landfill them. But it's an enormous amount of plastic that's being used and potentially exposed that can get into the waterway. 250 pounds per acre is used for plastic mulching, and approximately 10,000 acres per year in Michigan is using this particular technique. Plastic is even used to encapsulate fertilizer that's used for agricultural growing of various types of crops, and even the seeds that are used by the farmers are encapsulated in plastic. So the thing is that this plastic doesn't go away. It's in the environment and ultimately ends up into the water area. We've all seen this in urban areas, stormwater discharges just from litter along the streets that get collected, that potentially go into a wastewater treatment plant, or they get discharged directly into a tributary on the beaches, in the areas near the lakes, broken down, and ultimately end up in the water. Another source are landfills, and this is really some relatively new research in Great Britain, looking at landfills in regards to what materials are in there, such as sludge, garbage from residential and industrial waste, and incinerator waste. All gets piled into this area with a liner material, which, when a lot of stormwater ultimately gets embedded and infiltrated through the pile, it can go into a pond, or it can get leached into the groundwater, or it could go through surface runoff, can go into the surface waters. So this is just one way in which microplastics can really be moved into the aquatic area and also in through the groundwater. Industrial discharge is another source, and what I call nurdles, and these are little pellets that are manufactured, again, less than 5 millimeters. They're used for pre-production of plastic materials. So these come directly from the petrochemical companies, manufacturers. It's transported to plastic manufacturing facilities. These nurdles get transported, stored, and ultimately handled through the production process of plastic manufacturing. The problem is they get spilled a lot, huge amounts of material. So you may have seen this on the beaches when you're walking around on Lake Michigan, seeing these cylindrical particles that really can be ingested by various types of marine animals, and they basically absorb chemicals such as PCBs and mercury. So a little bit about the ecological impacts, and like I said before, it's complex. Plastics is a complex issue. The research necessary to determine what the impact is to humans in the ecological environment is really complex. I'm not going to talk about this in detail, but this is just a flow chart of what has to be done in terms of an approach of looking at the toxicological aspects of plastics on humans and also the ecological biota. And there's a lot of arrows and a lot of internet connections that need to be evaluated. So again, gives you a sense of the complexity of the problem. In regards to impacts, in terms of potential human impacts, again, you've probably heard this before, each person in the United States, man, woman, child, we take in about 5 grams of plastic a week. And that is startling. And it's through the water that we drink, primarily, the food that we eat, and also the air that we breathe. So those are the 3 main mechanisms of how we get plastic into our body. Plastic is such a problem, such an occurrence that's even crossing the placenta and getting into developing children. They're endocrine disruptors, as I mentioned, and there's also a potential for a food chain consumption by people eating fish, vegetables, etc., that contain these plastics. The ecological impacts is that metals and toxics absorb onto these surfaces. It can create a toxic environment. Fish can mistake these plastics for food. You get a magnification as the fish eat or get exposed to these types of materials, and it brings it again up the food web up to the humans, and also can affect the ecological impacts of fish viability and reproduction. So again, really more research needs to be done in this particular area. Just a really quick example of the movement of chemicals from microplastics. This is a microplastic piece here, where I mentioned that a lot of the material, the additives that are in the plastic, once it's released into the environment, this material leaches out of the plastic material into the water column area. Where they have such a huge surface area, the plastics absorb various types of chemicals such as PCBs, herbicides, DDTs, etc. So kind of like these plastic materials give a ride to these toxic materials, and ultimately can affect the fish that ultimately ingest them. Just a quick picture of what I'm talking about in terms of ingestion. You can see what the nurdles look like in this particular fish here, and the plastic fragments material in the one above. So talk a little bit about controls. The problem is that once the plastic is released into the environment, it's impossible to remediate. It's released, it's gone. It either goes into the sediments or it's released within the lake area downstream or down current. So it's almost impossible. So the key is source control, stopping the plastic from ever getting into the lake body to begin with. And this can be done through agricultural controls that I talked about, industrial controls, stormwater management, controlling the litter, plastic material, having humans change their behavior in regards to beaches, no smoking, actually reducing the amount of bottled water that they're using. We can improve wastewater treatment facilities, which I'll kind of talk about a little bit later on, but the key is source control. Stop the use of plastics, especially if they're single use. In regards to microfiber controls, there's two major ways to do this. One is changing the type of material that's used instead of using synthetic materials for clothing, called material substitution. So going back to more natural fibers, such as cotton and wool, there's a lot of research being done by Patagonia in regards to looking at this type of concept, getting away from those synthetic materials and going more natural. Even looking into biodegradable type materials, such as kelp and various types of proteins. Then you can get into the type of washing machines that people can use. There's one particular machine, it's manufactured right now in Great Britain, where it has an internal filter embedded within the machinery of the washing. So again, collects a lot of these microplastics from getting into the wastewater. So it's got a 90% removal of microplastics, which is relatively quite high. Then we get into various types of washing machines. The side loading generates less microplastics than top loading because you have that rotating agitator in the top loading that breaks apart more and more fibers. It's very possible in the future, these could be regulatory requirements. I hope in the Great Lakes, because this is one of the major ways of really controlling the microfibers. California is really looking at a regulation to require this, and also France and the United Kingdom. I'm going to talk a little bit about wastewater treatment. Wastewater treatment, once it's collected by a wastewater treatment facility in municipalities, there's basically three types of treatment. There's primary, there's secondary, and there's tertiary. And so I'm not going to go into excruciating detail about this, but this really requires more settling. This is biological treatment, and this is more chemical and physical treatment to basically reduce the amount of pollution coming out of these facilities. So in regards to microplastic removals, wastewater treatment plants are very efficient in terms of doing this. You have wastewater treatment facilities that can basically, when in series from primary to secondary to tertiary, they actually were able to go over 90% of the removal of microplastics. So again, kind of gives you a snapshot of how efficient the microplastics are at wastewater treatment plants. It's an industrial facility. These are really simple, just basically capturing spilled material through various types of inlet structures, employee training. The nurdles do not necessarily have to get into the water. It just requires best management practices. Nurdles were such a problem in California back in 2007 that Governor Schwarzenegger signed a law, the Nurdle Law, which basically requires industries to basically control the amount of nurdles that are being spilled and actually do something about it in terms of its collection. And this is, and the reason why in California was they're looking at the toxic effects of humans and animals from the additive compounds in the plastics. So this is a very progressive law that Arnold Schwarzenegger signed in. Another regulation in regards to the Great Lakes is from Senator Durbin. Senator Durbin has proposed the Plastic Pellet Free Waters Act to address water, pollution in the Great Lakes. Again, these are more focused on nurdle management. The last regulation I'm going to talk about is the Break Free from Plastics Pollution Act. And this is kind of like the home run ball in regards to the dealing with plastics. It deals with how plastics are manufactured, where they're manufactured, recycling requirements, microplastic controls. So most everything you can think of in terms of microplastic controls is really embedded in this bill that is still waiting for passage in the House of Representatives. So, big picture recommendations. First of all, what can be done? There needs to be better coordination and activity associated with research and a coordination of understanding between political leaders, such as the International Joint Commission, state leaders, researchers at universities. There needs to be a communication about what the problems are and what we need to do to address them. We can address into actual solutions-based research by universities, promote public knowledge and education, expand those risk assessments of really understanding what the risks are to the human and ecological populations, improve source and fate models like computer modeling. If you don't know where the material is coming from and where it's going, you can't really well manage it. Initiate water quality-based management plans and promote best practices, such as in industry and agriculture. So what can we do at a lower level of addressing plastics? There's just some ideas. I think the important thing to recognize is that we cannot recycle our way out of this plastic problem. The manufacturing is just too huge now and in the future to ever think that recycling is going to solve the problem. Modify the decisions not to buy plastics. It's not easy, but it's a personal choice of how we end up buying our materials and the clothes that we buy. Look for natural fibers in clothing. Put filters on our dryers and our washing machines. Avoid single-use plastics. Don't buy bottled water. Contact your local state and local representatives to tell them you're concerned about microplastics in the water and you want something done about it. Support future legislation. promote public outreach and education about the problems associated with microplastics and what's occurring in the Great Lakes. Develop letters to the editor. And probably just as important is really teach your children about plastics and microplastics and some of the issues. So yeah, in summary, microplastics create a potential huge impact in regards to the water quality in Great Lakes. They're numerous, it's complex, we need more research. They have been known to absorb and leach toxics into the Great Lakes. There's no regulations right now that control plastics within the Great Lakes. Microfibers are the major plastic problem in the Great Lakes. And it's going to take multiple types of controls. There's not going to be one silver bullet that is going to address the problems of in the Great Lakes. The next thing we do is we just need to basically, we need to address this emergent pollutant and get aggressive in regards to protecting the Great Lakes. So with that, that's the end of the presentation. And